This is now it's an honor to us actually that you are here and presenting. I would like to say that your selection has gone into a process. I would like to also say that most of the FYPs were deserving of course, being FYPs to the first place. You have been following with you on very many levels, and now you are here to present the best that you have. And all other FYPs will be on the proceedings too. However, except a few for good reasons. This is another important thing. It would be like maybe your first publication that you can claim to have done with review, and this is something we aspire to in our lives. So now you have done it even as undergraduate students. To make it short, you are here to make this presentation. You have the limitations, the 12 minutes presentation, a maximum of 2 minutes of discussion and then transition. And I'm sharing this session, but I'm not going to go up and down every minute. So I'm going to quickly read. If you are in here, please come in. Please, حتى الguest, you can come in. You don't have to wait outside. Reddy is a static student. He attends all CE events. I think he will win an award when he become an FYP later on. Thank you, Reddy, for being here. He's my student. Okay, so in quick, there are 8 projects. You should all be here right now. If any of your guys is missing or girls is missing, please call them to come now. You cannot leave. This is not a prison, but we really want to have everyone attending everyone else. It's a courtesy, and it's very important that when you become attendees of conferences, you don't come and leave. It's very unpolite to do so, okay? Because then the last group will be presenting to themselves. They need a mirror if no one is present anymore. So we have 8 projects. They will be in 15 minutes intervals. We are a bit late, but we will catch up. Low-cost construction using waste materials, organic structure. I think the title may have changed. I'm going to just read the starting words. Planning and design of the net zero energy building, Remedy 2. Rehabilitation of Shbaklu, secondary highway, sustainable construction, and sustainable refugee camp. So anyway, they'll be presenting themselves, and we can start immediately. I'd like to really thank everyone who worked on this conference, and our agonizing Rana, Dr. Rana, who has been really putting extreme effort, and I think today she will just giving the call to arrange something, I'm sure. So really, she has worked so hard, and you have all been. She also suffered a lot of complaints. I'm glad she's not yet collapsing, but I have been in there before, and it's really a very hard job to do. Thank you again for being here. So we have the first group. They will introduce themselves again. I'll be sitting in the back and watching, and then there will be some judges. Faculty members will come in. They will not all be the same at every time, and this is somehow random. Of course, if your advisor is here, it's your advantage. We call them. You can call them to come if they are not here. But I cannot force anyone to come at any time. But you will have, in many instances, many faculty members, including Dr. Maya in the back, and here we have 2 or 3 now, and they'll be coming back and forth to make judgments. There will be an award for 2, the best 2 papers / presentation. So it's not like if you do the best presentation now, which may be the case, but then we have to reevaluate, and there are ways to do it between everything, the whole combined thing, and you are all winners. Again, when you put this under your CV or anything, paper accepted and presented in a peer-reviewed referees conference. This is by itself, it's really a very prestigious idea. Thank you.
Can we just remind them that there's the award session this evening? Yes. Everybody has to be there.
Yes, of course. You have the reception. You have the reception in the evening where all the winners of everything. You know, some of you are also participating in other things, like the creative achievement, like the research paper, etc. They are also going to be announced in this evening, and you are all invited to be present. You might be expecting, waiting, or just we'll see what happens in the evening. Okay, it's at 7.
It's at the terrace.
It's at the terrace in case it's not raining, but I think they are moving it in case it's raining to the...
You'll be announced.
You'll be announced. Okay.
Okay. Okay. All right, so So we're going to be one session late.
Prevent you from the sea view from the
Yeah.
much better.
شو المشكلة؟
How do you get this done? The other.
على الأخير. صاروا كيف معالي
All right, خلاص, let's just start. Can you just start, please? It's 9:15 already. Okay? Go.
So good morning, everyone. By way of introduction, my name is Karim. These are my colleagues Sarah, Sana, Ala, and Muhammad.
I'm Munir.
Today we'll be presenting to you our FYP topic, which is low-cost construction using waste materials.
It's fine, you can just go. Like, ماشي الحال.
Let's start off with a quick outline of the presentation. First of all, we'll start with a brief introduction, then we'll tackle the methodology and results, then we'll talk about the mode design, the application through a case study, then perform a small sustainability analysis, and then conclude. So, let's start off with the introduction. The amount of natural resources that are being depleted and the increasing rate of waste production are something that cannot be messed with. Therefore, it is important that we develop a new approach that has the theme of sustainability in such a way that future generations can still benefit and get their fair share out of the global resources. Let us take an example. We're all familiar with the basic building materials that we use, such as concrete, steel, timber. However, what's common between them? We should not think of them as a final product. We should think of them as a series of processes that culminate into the final product. Each one of these processes produces a byproduct or a waste. And it is our job, and an example of these wastes is lime material, which has no immediate solution to it. They still don't know what to do with it when they produce it. Therefore, it is our job to find a way of how to integrate such byproducts in a way that can benefit society. Therefore, this brings us to the main topic of our presentation, which is creating a sustainable masonry unit that has the properties of structural integrity and aesthetics, and at the same time highlighting the overall environmental aspect of the block. And therefore, we are mainly interested in 4 key pillars, which are sustainability, cost, structural integrity, and greenery. I will now leave the floor to my colleague Ala.
Okay, so regarding the waste material that was considered for the production of our block, we choose the lime dust from a marble cutting plant. The first step is to know the properties of this material. So by manipulating it qualitatively in the lab, we concluded that it absorbs a huge amount of water. Also, by conducting a compressive test to this material, we concluded that it has a low compressive strength. Now, in order to increase its strength, we decided to add to it cement. But since cement is considered as pollutant, we tried to minimize the quantity of cement used. So cubes of lime with different percentages of cement were tested. Ranges from 5% till 20%. We decided to go with 15% of cement as an optimal mix. But while conducting the compressive strength test, we noticed that the failure was brittle. So in order to increase the ductility of this mix, we decided to add wheat straw fibers that can increase its ductility, but the strength remains the same. The final problem that we have faced is the huge amount of water that needed to be added to the lime. So in order to solve this problem, we decided to use sand as a filling material. The using of the sand not only decreases the amount of water needed, but also increases the strength of the mix. So based on the results obtained, we decided to go with mix 4 for our block.
The design of the block unit integrates several features, including aspects of reinforcement, greenery, and interlocking mechanisms. In terms of reinforcement, in a paper published by Dr. Shahab and Dr. El-Miski on the use of geogrids, different types of geogrids, and thin layered concrete beams, it was shown that indeed geogrids in its different shapes can help provide, can serve as reinforcement for the concrete beams and can increase their ductility. And since we are using plastic grades in our block, which mimics to a certain level the shape portrayed by uniaxial geogrids, we have reason to believe that it will provide an reinforcement for the overall structure of the block. This is the mold by which we poured our block in. Alright, so in terms of the connections between the blocks, the trapezoidal prismatic shape on top of each will provide us an interlocking mechanistic system that allows for the blocks to be casted like ladders. So for each two blocks, they will be interlocked by the block above them spanning the centers of each. Okay. In terms of greenery, we have to think of a proper irrigation and drainage system to be designed and embedded in the design of the block itself. So in terms of drainage, the sloping sides of the hollow inside the block will allow for the drainage of water so that it does not overflow the soil or cause suffocation for the plants inside. And in terms of irrigation, it can be as simple as spraying the system with a hose of water, or you can go as fancy as you want, like using the systems embedded in green walls, by which you can use a snake-shaped like perforated tube, which allows for the equal distribution of water to all the block units.
This innovation could be implemented in several applications, such as walls, fences, and agriculture storage rooms. For our case, we, in fact, a 3.9 by 3.9 meter room was modeled and analyzed in ETABS to show that to prove its to show that it can was modeled and was a 3.9 by 3.9 room was modeled and analyzed in ETABS to show that it can sustain gravitational loads and wind loads based on the UC 97 load combinations. Okay, so we modeled this room on ETABS. This is the undeformed shape and this is the deformed shape. As you can see, there's some deflection above the door opening, but this will be taken into account by placing a 10 centimeter thick concrete beam. Okay. So the model was assessed based on maximum allowable sway of 6.8 millimeters, and in our case it was shown to be 0.1 millimeters, which is acceptable. And for the deformation, the allowable value was 2.78 centimeters based on the ACI 318 code. The value obtained was 1.1 centimeters. This shows that those are acceptable results.
So we know that if for a product to be sustainable, it has to meet the needs of our own generation without compromising the ability of future generations to meet their own needs. So we have three pillars of sustainability: the economic aspect, the environmental aspect, and the social aspect. In order to see if our block is sustainable, we need to assess these three criteria. So first, concerning the economic aspect, the cost of one block is $2.83, and the number of blocks used in this structure is 217 blocks. So the total price of the room is around $613. So let's compare now the price of this structure to the price of the same structure but using a standard masonry unit. So the size of one block is equal to 5.5 times the size of one masonry unit, which costs $0.6. So for the same structure, the cost will be, using masonry units, $716. So we can say that we have a saving of $100 when building a room with the block that we designed. Concerning the environmental aspect, Our block is eco-friendly because it uses a small amount of cement while using large amount of waste such as plastics and lime dust. Also, it integrates aspects of greenery. This is why it is also environmentally friendly. Finally, concerning the social aspect, the block is affordable for low-income people, and also since we have greenery in the block, it helps us in the aesthetic shape of the room, which provides well-being to people.
Now, regarding the main limitations for our project, obviously the size of one block is huge. Its mass is about 80 kilograms. So this is one of the limitations that are present in our project. Another one is the fact of the scarcity of sand. But remember this, we used sand as a filler. Another option was to use aggregates. Why did we not use aggregates? Because to do aggregates you need to crush, and crushing requires energy. So in terms of comparing both together, the lesser sustainable option would be the aggregates. That is why we went with the more sustainable one, and we chose sand as to be our filler. And all in all, we believe that our product is innovative. It integrates a multitude of waste to generate an outcome that can be used for the benefit of society. And we, the eco-builders, believe that we took the first step towards a greener, sustainable future. Thank you.
Floor open for questions. Okay. You have questions?
Yeah, there's a question there.
There is sand. Could you use plastic, crushed plastic, or not? Replacing sand, can you use crushed plastic?
We could have used crushed plastic, but the fact that crushing the plastic in itself requires energy. So this isn't sustainable. Any other questions? Thank you all.
By way of organizing, I'm sorry, I'm doing my job from the back. By way of organizing, as soon as the presentation finishes and they are asking for questions, the next group will move immediately and prepare themselves and don't need to again disturb us on this. And make sure that all your microphones, we also are presenting, make sure that the microphone is right back so that we can all hear you.
Yeah,
It's part of the training. The microphone should always be well held next to your mouth. Don't move it ahead, don't move it around.
Good morning, everyone. We are the Hive team.
Again, it's not an easy job. You always forget it. People do it right.
Okay.
Yes. You're singing now.
Good morning, everyone. We are the Hive team. Hala, Ghadir, Hussein, Angela, and myself, Farah. And we'll be presenting our final year project about generatively designed organic structures. 2 billion tons. This number represents the amount of CO2 emissions from cement production per year. And it's equivalent to approximately 8% of the global CO2 emissions. 4 billion tons. This number represents the amount of concrete production per year. And it costs approximately $452 billion annually. Those two numbers are really big, right? But the problem is even bigger. Year after year, population growth and urbanization are imposing more demands on the construction industry, which is depleting our resources and harming the environment. So, in order to decrease this extensive demand on construction materials, Beehive team decided to prove the concept that optimization of quantities is possible for structural elements. To do so, we designed an engine that optimizes concrete and steel quantities for a cantilever beam. Our story started by an inspiration that enabled us to generate and explore the most convenient solution for our problem. Have you ever wondered how the tree grows in the shape that allows it to carry all the loads imposed by the fruits on it? Or the reason behind the shape of our human body? The key is that nature grows in the shape and direction that best fits its function and conditions. This concept is called generative design. Several other industries are mimicking this concept in their design, such as aviation, railway, energy, robotics. However, we have a problem. Construction still lags behind in this field. So, let's dive into an engineer's head, where all the goals, the dreams and ideas are being processed. The goals are to produce structures that minimize CO2 emissions and cost, that are serviceable and strong, and don't fail, using the methods that are computers and algorithms to synthesize designs. Okay, so to design this concept, variables were defined, and the variables include concrete beam depth as well as steel reinforcement ratio. And we did this on a cantilever beam. We did structural analysis on a cantilever beam, designing for flexure, shear, as well as checking on deflection. To illustrate the optimization process, a four-step cantilever beam was studied based on conventional structural methods from the ACI code. However, the moment weren't calculated by using the ultimate moment, directly the ultimate moment. However, we were calculating it at each section depending on the location. The beam shared a constant load that includes the superimposed dead load as well as the live load, but the self-weight differs based on each section, since it includes the H parameter, which is the beam depth, and this differs from section to section. We'd like to point out that the moment and shear were calculated at the first section using this equation, and then for each consecutive section, they were calculating considering the self-weight of the new section and the self-weight of the previous sections as well. Okay, so now it's time to develop the algorithm, which is based on optimization techniques that include the Lagrangian multiplier as well as the genetic algorithm. The objective functions are to reduce cost and CO2 emissions, and all of this is based on certain structural constraints. So, as we can see, that the volume of concrete as well as mass of steel appear in the objective functions, and they reflect the decision variables. Not to forget that the first objective function is to minimize cost, the second one is to minimize CO2 emissions, and a third objective function, which is a multi-objective function, it includes both factors. As for the constraints, they're mainly for lower and upper bounds of concrete beam depth and lower and upper bounds for steel reinforcement ratio. And we have to check that the ultimate moment capacity is less than 0.9 of the nominal moment capacity. Now that the algorithm is developed, it is time to set the inputs. The inputs include beam dimensions, which are width and the length of the beam, as well as the increment size, which divides the beam into several sections. The loads applied, the material properties, and cost and CO2 emissions that were that appeared previously in the objective functions.
All of these were coded in MATLAB in order to solve for the optimum solution. And this is a sample of the run of the code. And this is a sample of the different designs generated for several increment sizes. Now that the MATLAB generated the optimum beam values for our design, it's time for exploration. And for that, although the
code can design any beam length or width set by the designer. We took an example of a 4-meter long beam and a 30-centimeter wide beam. And these graphs show the variation of the depth of concrete starting from the free end, which is 0, towards the fixity, which is 4. And it can be seen that compared to the conventional, which is the black line, a lot of volume reduction was able to be achieved using our optimization engine. Even for the largest increment size, which was 1 meter. And as the increment size decreases, the value of the depth becomes more linear with time and even with location, and even a more reduction in volume is achieved. Similarly, this applies for the area of steel at every location. Even though the conventional method might give a smaller value towards the fixity, but if we look at the total volume of concrete, which is the area underneath the curve, we are still able to achieve lower total quantities. In order to evaluate the effect of the reduction in material quantities on the costs and emissions for all the 3 objective functions we considered, it can be seen that we were able to achieve significant reduction in cost and CO2 emissions with the optimization. And obviously the cost objective function was able to achieve the lower costs possible, and the CO2 objective function was able to achieve the smallest CO2 emissions possible by the beam, while the multi-objective function, which is the middle line in both graphs, was able to compromise both aspects. In fact, we were able to achieve 33.6% total reduction in cost and 29% reduction in emissions. On average, 102 kilograms of CO2 per beam were able to be achieved, which is equivalent to carbon sequestered by 2.6 trees grown for 10 years and 250 passenger vehicle miles driven. Although this might not be very significant for one beam, but if we scale it up for an entire building or an entire country and even the entire world and for the entire structure, we will indeed be able to achieve more significant reductions in emissions and costs.
Structural optimization allows us to design complex organic shapes, such as the structure shown in the following figure. But the question remains is how to build such a structure. Currently, the formwork system required to build complex structural elements is time-consuming, labor-exhaustive, and complicated. So we need new technologies that allows faster and easier construction process, such as concrete 3D printing and steel 3D printing. Although these technologies are still in their infancy, but they have a promising future in the construction field. Now, in order to compare between conventional construction and 3D printing, choosing by advantage analysis was performed according to common attributes between the two processes. Conventional construction allows us to build projects regardless of its size, but with limited complexity, using less complex equipment and labor expertise. On the other hand, 3D printing allows us to build projects with higher complexity using less resources. Furthermore, 3D printing is considered fully automated process and formless process, which minimizes labor intervention in building the project. Thus, it reduces safety risk, CO2 emissions, cost of the project, and the project delivery time. So, as we can see here, the 3D printing sums higher over all the attributes, which conclude that it's a better alternative for construction of optimized structures.
Even though this project only tackled a single structural element and not an entire structure, promising results showed that generative design can be applied to the structural field through optimization. What if you can generate thousands of options without drawing? All the designer has to do is to determine his goals, and the computer does all the generations for him. He would then choose his better option, the one that meets his most important criteria, one that he could not have possibly ever imagined. Using massive computer powers, creating forms using precise amounts of materials in the right places needed can be achieved while wasting nothing. Thank you. combined into objective? No, they weren't combined in one objective function. They remained to be two separate objective functions. They weren't combined into one objective function. They remained separate as two objective functions. However, using MATLAB, we use a function called GA multi-objective, which uses genetic algorithm in order to evaluate to optimize for the both functions. So the weights were divided equally for both. Any other questions? Thank you.
Good morning. I want to start by thanking the organizers of this conference and thanking them for giving us the chance to participate in such an important conference for future ideas and innovations. So our group is Amirha, and our project is the planning and design of a net zero energy residential building. So I would like to start this presentation by saying I'm sorry. I'm sorry for ruining what was once a habitable planet and not letting future generations enjoy it like past ones have already did. I'm sorry we use nature as a credit card with no limits. I'm sorry we pay more attention to ISIS and not how fast the ice is melting. And I'm sorry that we have depleted all our resources and we have no other choice than to save our planet, which is the only one that we can reside in. So this is why our project is a breakthrough could be a potential breakthrough in the construction industry and the welfare of the environment. So I present to you the Net Zero Energy House. The Net Zero Energy House has all the components of achieving the zero net energy goal, and you will see them with our colleagues.
Okay, so now we are going to start the site selection. The site selection has a huge impact on the design of the house and on the ability of the house to achieve its zero energy target. So we evaluated many criteria for the site selection. The most important one is the ability of the most important one is the solar access, and the other factors are also exist, such as the ease of construction. So accordingly, we decided that the location of the site would be Balune, since it balances between the cool climate in the summer and the moderate to weather conditions in the winter. So it would be perfectly suitable for our site and for the solar access. And in addition to that, it contains many areas with no tall buildings around it. And it has access to infrastructure and transportation networks, and there are many flat lands in it, so that there will be ease of construction. Now, according to the sun path diagram, the location of the sun in Lebanon is concentrated on the south throughout the year. And according to a study done by Windfinder, the wind direction in Lebanon is mostly southwest. So we decided to place our home such that the living areas are facing the south, so that we could maximize the solar effect.
So to reach our net energy target, we had to design our house using passive design strategies. So we had multiple options. We first started with the heating mechanisms. So we first designed our house in a way that will benefit from the solar radiation throughout the year. That's why we assessed our rooms into several thermal zones. For example, we placed the kitchen on the east side to benefit from the morning sun. So this will have a warm space for breakfast. Our living space, our living area, and the dining space, which are used throughout the day, were placed on the south side to benefit from the sun throughout the day. And the bedrooms were placed on the east side and the south side. So the preference is to have sun during the morning, and if not, any access during the day. Then we designed our roof in a way to increase the area for the south facade, to have more space for solar panels. And we had an opening in the roof, so this will have solar access for the rooms in the north side, in the north facade, in the north side of the house. Then we optimized glazing on the south side. So as you can see here, this is the south facade, and we increased glazing as much as possible to benefit from the incident solar radiation, and we decreased them in the north facade in order to minimize the heat loss. So we had a limited number of small windows in the north facade. And finally, in order to retain the heat that we trap inside the house, we designed proper insulation that will be discussed furthermore in the structure section. Then, during the summer, in order not to have overheated space, we designed our house to have proper shading mechanisms. So all our mechanisms rely on the fact that the summer sun is usually oriented at a 75 degrees angle, while our winter sun is oriented at 35 degrees angle. So we first had overhangs. As you can see here, our second floor is have an overhang from the first floor of around 80 centimeters, and our roof is also have an overhang. And as you can see, the summer sun will actually will be shaded during summer days, and the winter sun will have solar access into our living rooms and bedrooms. Then we designed fins. The fins are placed here and here on the east and west side of the south facade. So these will actually shade the morning and the afternoon sun, only during summer time. So as you can see, in summer mornings the rooms are shaded, but in the winter mornings we have solar insulation. We have solar access for our rooms, and this applies the same for the afternoons. We also placed vegetative shading on the east and west facade, but these were placed on separate steel sheets, not to affect our wood structure, so we won't have any problems. And we also placed sun tracking Venetian bands in the living room and the bedrooms to further improve our shading efficiency. These will be discussed also later. So this is so we assessed our structure using Ecotech. So this is during winter times. As you can see, we have solar access for all the rooms, while during summer times, the windows are actually shaded. We also optimized ventilation. So in order to optimize ventilation, we designed our windows in a way to have simple ventilation mechanisms. We had small windows that can be left open even if no one's in the house for safety reasons. And we also made sure to have cross ventilation. So since the wind is actually oriented southwest, we'd have the wind coming from up, and we designed windows on the other side in order to provide proper ventilation. Now we'll talk about construction.
Okay, selecting the construction material depended on many factors. Most importantly, the embodied energy of the material. As we can see here, concrete and steel have very high embodied energy, so we decided to go with timber. For this reason and for other reasons, such as large insulation capacity for timber, and it is sustainable because it's naturally renewable and it is reusable and recyclable. Our structural system was the wood post frame system, because it relied heavily on wood and also it could achieve high R values because of the wide spacing between the columns. Moreover, it is structurally stable because of the low weight and the flexibility and the unity of the structure. Okay. Also, it uses fewer material compared to other type of structures. Windows use the double glazing with low emissivity paint from the inside only to conserve the heat inside and allow the sun to enter our house. As is shown here, the radiation from the inside is reflected back, most of it. For wall insulation, we use the thermocork insulation because it has a negative carbon footprint, and also it has a high insulation capacity. 5 inches board gave us the R value that we needed. Knowing the R values and the type of windows, we added them to the Ecotect model of our building, and we made a thermal analysis which gave us this graph. It shows us for each month how much energy, watt hours is required for heating and cooling. As you can see here, it's very minimal. The only problem a little bit was in July and August because we needed cooling in the house. However, because we couldn't model the ventilation that my colleague talked about in this program, we are sure that this value would be much less if we could add the ventilation, cross ventilation. These are the values in numbers. It is 780,000 watt hours, which is 780 kilowatt hours, which is very minimal to the average required heating and cooling energy in Lebanon.
Okay, so now I'm going to talk about the lighting. So lighting is one of the components of the house that consumes energy. So good and efficient lighting is an essential part in helping us meet the zero energy target. And to reach that target, we need to consume as much as we produce. We cannot consume more than we produce. And in a typical Lebanese house, lighting represents around 15% of the total electricity used. So the aim is to cut these 15% as much as possible. And yes, so the aim is to cut those 15% as much as possible. And to reach that target, just a second. Oh. So yes, to reach that target, just a second.
Not the right word.
It's okay, continue.
Okay, right. No, to reach that target, lights are used at night. So mostly used at night. So we are unable to provide directly the solar energy that we cannot provide the energy that's used for lighting with solar energy. But the solar energy that is accumulated during the day, so the surplus of energy that you accumulated during the day, would help us compensate for the lighting. And so this is why the lighting design is a major stage in the construction of the house. There are many components that the lighting design is based on. The most important one are the volume of luminance that is essential for the job, the position and quantity of light used, and finally the nature of lights. For the nature of lights, talking about the nature of lights, and we're planning to use LED lights throughout the whole house. Why are we planning to do that? Because LED lights have 3 main advantages. The first one is energy efficiency. So it's 70 to 80% more efficient than a normal bulb. The second one is the service life of LED light. The service life of LED lights is much higher. It's 5 times more than a compact fluorescent. And finally, the material used. With LED lights, the material used for replacement bulb is much less. And finally, to control the lighting of the house, we're planning to use the light balancing system from the 2 market leaders that are Somfy and Philips. So basically how the system works is complementary between natural lights and artificial lights. So if, for example, natural light is blocked by cloud, okay, so the natural light would be at minimum, as you see in the first stage up. The artificial light would be at maximum. And for example, if the natural light is at maximum, the artificial light would be at minimum. And Philips controlled the artificial light, and Somfy controlled the natural lights by moving the curtains. And talking about another material.
You have 1 minute to go.
Okay. So in order to reach our zero energy goal, we have opted for solar energy using PV panels on the south facing side of the roof. That will generate more energy that we are projecting, and the excess energy will be stored in batteries to be reused later on during times of need. For water heating, we are using hot water collector plates that collect heat from the energy's solar radiation, and the flat plate is insulated not to lose heat back to the air. For water systems, there are two main concepts that we opted for in order to meet our house's water needs. The first one is rainwater harvesting, which consists of placing a 5,000 liter underground tank that collects rainwater to later be used for watering the garden, flushing the toilet, and washing the clothes. And another concept is grey water recycling, which consists of recycling this water used for these three main usages in order to use it again after filtering it to flush the toilet and wash the clothes again.
Okay, although final thought.
Yeah.
Conclusion. Okay, so although we designed for the house and everything, if the occupants don't perform and don't integrate into the thoughts sustainability, the house on itself will not work. So they have to work together to achieve this goal altogether. Thank you.
I'd like you to, I'm not sure why, but if you do that in the FYP, there'll be a very major problem. You're not acknowledging any of advisors who never helped, etc. So I think this is part of the presentation. So those who did not, that's fine. You might have just 10 seconds, 15 seconds to acknowledge who was busy on this project from now on. Just the question.
We actually skipped the conclusion, and the conclusion acknowledge all the work.
Then show the slide. Then show the slide. Show the slide that has acknowledged.
It's all the conclusions, only pictures. Slides are only pictures.
So these are 5 years from now? Huh? Next year?
لا ما تأثر 12 minutes on the dot.
Okay, since we're also doing some learning experience here, you will benefit from it for your next presentation. You try not to move around during the presentation and block the view. If one is presenting, the other should not be like, floating around, because you need to focus on this. One person is presenting, the others are statues, okay, standing. And use the pointer if you have a pointer, right? Somewhere. Use it if you need to, just rather than go and block the screen. Go ahead.
Hello everyone. Today we will present to you something you may have already heard about, but from a new perspective. Ramli 2.0, rehabilitation of Ramli al-Bayda. So first, where is Ramli al-Bayda? This is a satellite image of Beirut. AUB is at the top edge, and the area under study is outlined in red. So why Ramli al-Bayda? Personally, I've never been to the beach area in Ramli al-Bayda. The word of mouth is that the area is not really attractive as a recreational spot. And when we visited it, we found out that it suffers from a much greater problem. For example, if we look at the end of the shoreline, we found a massive sewage outfall dumping straight into the sea. And if we look at the beach facilities, we find that they are mostly destroyed. And finally, the sand, although it looks clean and intact in some areas, in most of the areas it's highly contaminated with solid waste. So this is where our project interferes, in order to rehabilitate the beach. And since Beirut area has one of the lowest green ratios in the world, of less than 10%, we decided to rehabilitate the already existing public garden close to the beach, and then link both areas via pedestrian highline. So to start with, this is the outline of our presentation. We'll start by the existing conditions, move to the methodology, results, and finally the outreach. Starting with the existing conditions, this is the overview of the beach area of Ramat Al Baida. Here we can see the sewage outfall dumping straight into the sea. This is the poor access to the beach. It needs renovation. These are the existing beach facilities, such as changing rooms. This is the current recreational area for kids. And this is the public garden, which is very close to the beach and overlooking onto the sea. So now, Jad will present to us the methodology.
So first I'm going to talk about the assumptions, and specifically the land ownership. So there has been a lot of political debate and controversy about Ramat Al Baida recently. I don't know if you've heard about it. So the garden is owned by the municipality while the beach is privately owned. So in this project we're not concerned with the political and legal aspect of ownership. So we're just assuming that all the area is publicly owned by the government, just like any other public space should be. Our next main assumption is about the sewage outfall. We assume that the outfalls will be redirected to an existing adequate treatment plant, just like also it should be. And then we'll talk about how we made the 3D model and how we went from a simple idea to an almost tangible concept. So first we went to the field to see the reality that we were dealing with and to have a better understanding of the space that we're dealing with. And so we acquired AutoCAD plans of the area and we imported those on a program called SketchUp. So using SketchUp we did the 3D model of the area. And after refining it and designing the multiple components, we rendered it using a program called Lumion, which you will see in a few slides. Finally, this AutoCAD here shows you the land on which the garden covers. So we chose to design a parking facility on this land, underground parking facility. And so we used the Lebanese building code or Kanun Bina to design the parking for the turning radius, etc. And now my colleague Joanne will present to you the results.
So now we will present to you our results. We're going to go from the general overview to the details of each result we got. First of all, this is we're going to skim through the SketchUps just for you to get the location of each segment we studied. First of all, this is the garden, the public garden. Here it is. Now for the highline and pedestrian connections, as you can see here, the highline connects the public garden to the beach, and we have three main axes, one here, and one next to the pier area under retail. As for the sports area, it's here. It's the same location as the current, where there's a football court currently. As for the restaurants and cafe, we decided to put them here because it's right next to the highline, so easy access for pedestrian. And for the retail area, we decided to put it here and here, right next to the beach and right next to the people walking on the pier. As for the pier area, it has the most iconic attraction we have at Ramle 2.0, which is the Ferris wheel. Now for the garden, you are looking at it from this side, so bottom up. As you can see at the bottom, we have the kids area, playground, and then as you go up towards the top of the garden, we also divided this. We took into consideration people in wheelchairs, so this is the wheelchair ramp and the stairs. As you go up, you get to the main entrances, one here and one here, and there are a security booth on each matrix to keep things under control. As you reach the top, you want to go to the beach, you have to take this connection here, which is the High Line, Here, an issue was pointed out by residents living nearby that the level of the highline here is right next to a building, the building which is here. So we decided to resolve this issue by planting trees here in order to resolve the privacy issue. As you can see, this is the High Line we designed. It connects the public garden to the beach by this connection right here. Here you can see another view, which you are looking at it from the public garden towards the beach, where you can see that when you go to the connection here, and you can go down to the beach. This is another view from an elevated view from the beach. As you can see here, there are the restaurants and cafes. We decided to put them here. And so this is just another angle for you to see the High Line. This angle shows us what pedestrians walking on the streets will see. And this is the connection between the public garden and the beach. Finally, this is another issue that was also pointed out by residents that walk on the street here. They said that if you build the High Line, maybe we won't have any more sea view while walking on the street here. But this is to show that it's not true that when you walk here, you can benefit from the sea view, even though we built the High Line. Now Jacques will continue with the beach.
Now for the beach, the major part that we implemented is the recreational part. It consists of components like water sports, beach sports, cafes, restaurants, food and beverages, and most importantly, the promenade along the pier, including the Ferris wheel and major attractions. Now, the water sports includes paid activities like wakeboarding, wake surfing, jet ski rental, and sailing. From another side, for the beach sports, they are located on the left side of the pier, and they include the two beach beach soccer fields, two volleyball fields, and two basketball fields, including a playground for kids and an outdoor gym. All of these activities are designed to enhance the experience of all types of group of people, ranging from hyperactive youth to family and kids and even tourism. Now for the retail part, we implemented a big project including retail, which is very important because it promotes the local workforce. It promotes the local workforce, and it promotes the income of locals, and it gives taxes to the local government. Now you can see first here a view standing on the pier and looking towards the recreational areas that I talked about. And here you can see a view standing on the aerial view from the pier along all the beach. Now for the parking that we designed, it has a capacity of 187 cars. Here is the plan of the first level, which consists of 87 cars. It has been built underground under the garden to prevent building another concrete block in this beautiful landscape. Now, constraint that we did not took into consideration to prevent from losing our focus on our scope of the project and due to time constraint is thorough traffic analysis to perfect the design of the parking. And finally, solid waste management, which we all know is a major problem in today's beach, especially in Ramlet Al Bayda. Now I will leave the floor to Nadim to talk about the outreach.
For the outreach, we believe that our project can be implemented in the future. As such, we first designed a website. As you can see, this is the homepage of the website. You can know more about the food and drink, about the shops, things to do, the team, and you can visit our location and finally contact us. This is the food and drink page where you can hover over the restaurants to view the menu and the location. But this is only for viewing purposes and we do not contact the restaurants. We also designed the interface of our mobile application. So this on the left shows the homepage where you can choose between activities, shops, restaurants, renting a bike, and parking fee. In the middle, you can rent a bike, you can put your name, telephone, and the time of the rental. And finally, you can pay the parking fee. And here, this is the things to do page where you can view the activities that you can do. And now let's take a tour.
Do you absolutely need sound?
No.
I think we can skip the sound, right? We can just show the video. لا لا مش بلاها. Let's show the video but no sound. Guys, listen.
بس في صوت بس ما عم بيطلع في صوت كثير
It's very fast, you know, if you want the nice view. No table.
It's still informative. All right. Any questions? I actually have a question.
Yes.
So it looks like a really nice transformation, and a bit fancier than we would expect. Have you done any sort of cost analysis for this transformation or part of the transformation? Maybe just the necessities to make it, not to beautify it as much, but just to fix a couple of aspects.
No, the cost analysis was not done, but based on literature review, we know that this project, cost-wise, and it will be profitable because the profits outweigh the cost from.
Right. Okay. So if you're talking about the profit as well, another question would be, who would adopt such a project? Would it be the public sector or the private? And you think the government would actually take the risk on such a huge...
We did not go into these details to see if it's a private entity or a government entity because there's many barriers.
Yeah, it's just I'm trying to see the track of your thoughts.
Sorry to interfere, but now the beach is privately owned, which it never should be anyway. So this is the main concern. The beach should be publicly owned by the government, as I know.
Yeah, this was the basic political issue.
Like a debate within the land ownership, the lands are owned by different entities, so we did not go into this.
Okay, so you just looked at the design.
It's too complicated because even they could, it was not even solved, so we cannot go into this.
One aspect of the cost was regarding the parking design. Since it's located on a slope, so we needed to decide whether it should be located towards the high level or the lower level for excavation purposes. And another aspect is to decide how many underground levels we needed. So this is where we iterated on the design.
Okay. Any more questions?
How will implement it also?
You have the money? Rehabilitation of
promoting the idea of keeping the public beach public with all the controversies, and he had actually at some point to discuss it with higher authorities to make sure it's remains public at the time. And that's one of the most controversial.
فينا نقول للتشيرمان تبعنا نعيمة.
I can move.
ده بس كنا عم نحكي عنك.
تمرق ما بيأثر.
It's my group. That's fine. It's your group. Okay. Guys, let's listen. يلا. Should start.
Rehabilitation. In a few minutes, all of you here might ask yourselves, why would someone bother and go through the rehabilitation of a 100-year-old house? Why would someone bother and rehabilitate a 2-story house rather than building a tower with gardens and balconies, which might actually sound more profitable? But there is one thing that we are not keeping in mind, which is that once a piece of history is destroyed, we do not only lose ourselves, but we lose our identity, our cultural values, and our future generations. We are depriving the future generations of a true connection with their ancestors. Last of all, those who do not have a past, do not have a present, and do not have a future. My name is Diala Fawaz, and these are my colleagues Muhammad, Nadine, Noor, and Ala, and we will be presenting the rehabilitation of the Shba'al house.
This is the outline of our presentation. We're going to start with an introduction, followed by a preliminary assessment and testing, which led us to the analysis of the current state of the house. And then, based on this, we designed our architectural, structural, and MVP works. Then, a cost and schedule were developed, followed by a conclusion at the end. So, Shba'al house is a 2-story stone house. It's made out of sandstone mainly. It's located in Anem Raisi, and it was purchased earlier. 5 years ago by Ibn. And the ground floor, it dates back to the early 1900s. However, the first floor was added at a later stage. And there is a mezzanine between the ground floor and the first floor. It has only one access from the kitchen of the ground floor. So, this is how the house currently looks like. We're going to transform it so that it can accommodate its current use, which is offices. And this is how it will look like. We will preserve its historical aspect, but we will add some modern features to it as well. So to assess the house, we started through observations. Regarding the historical aspect, we found large colorful wood windows, corridors, historic tiles, circular air vents, and arches, in addition to the high ceiling of the house. Then, we investigated the presence of structural elements in the house. We found that there are protruding steel and wood beams in the ground floor at the longest span, and there are concrete beams and 2 exterior concrete columns in the first floor. And no interior columns were found. This was investigated using a steel detector. All the walls are made of sandstone also. So, then we examined the damage present in the house. We found a major crack on the main facade of the house, and there were clear signs of water leakage in the house due to the plants growing on the side of the plants, as you can see. Then we moved to the interior of the house. We find that one side of the house is the one that's mostly damaged, and this side includes the major crack we previously showed. In the first floor, there are two rooms that show significant deflection, one of which is the kitchen that had exposed corroded keyboards, suggesting that in this room the deflection is due to corrosion. Also, there are cracks in both floors and around the staircase.
Now the observation showed that the house is currently not in a habitable condition. Therefore, we decided to conduct several tests, such as coring, from which we obtained the compressive strengths of both the concrete columns and the sandstone walls. Also, we conducted a sulfate chloride test in order to determine, from which we determined that the corrosion that was found in the kitchen did not spread to the entire roof. Also, the stress under each wall was found to be less than 1/5 of the compressive strength of the sandstone, which indicate that none of the walls is in critical condition, however they are weak. Also, as my colleague mentioned earlier, the major cracks were located at one end of the house, which suggests the presence of differential settlement. Now, the main reasons of differential settlement are the following. First, the absence of foundation under one of the walls. Second, the presence of cavities in the rocks due to the nature of the rock, which is limestone. Also, the presence of eccentricity in the foundation, and the presence of voids in the walls. Moreover, seismic activity could have been the source of these major cracks because of the nature of the walls, which are sandstone and does not take movement. So based on taking into account all the assumptions, we decided the following. First, to relieve the old walls and the foundation from the stress in order to stop the settlement. Second, we proposed a new structure that renders the old structure redundant, and we also designed a foundation system for this structure in order to make the house resistant to vertical and lateral loads.
Now, the proposed structure is steel rather than concrete. This is due to the fact that steel has many advantages in our case. First of all, it provides a better aesthetic appearance when introduced into all structures. Second of all, it can have small sections supporting long spans. Third of all, you can have low weight, which renders a smaller foundation. And most importantly, by choosing steel, we are avoiding concrete-sandstone interaction, because since the concrete can expand and cause damage to the sandstone. Now, the proposed structure or design consists of 17 columns spread throughout the corners of the house and which are connected by beams. Now, these columns were placed inside the house to avoid breaking part of the walls. The walls are shown in white. Because the walls, as proved before, that they are bearing walls, no interior columns. The beams were placed in a lateral and longitudinal. The beams are placed such that there is a bracing system in the lateral and longitudinal direction. Additionally, the steel beams found on the ground floor, shown in red, are preserved and uncut in order to fill the new structure. However, the old concrete beams in the first floor were removed and replaced by steel beams in order to provide an overall continuity of the structure. However, the exterior concrete columns were removed since the balconies can be held as cantilevers. Now, concerning the foundation, the first assumption we took is that it is hinged. The connection between the column and the foundation is hinged, since we wanted to reduce the size of the foundation. However, and we chose isolated footings since they require the least amount of excavation of the ground. However, when placing this foundation, we had to avoid the old foundation. Thereby, the columns had to be placed on the corner of these footings. This imposed eccentricity, which was solved by micropiles under each footing, which take compression and solve the problem of eccentricity. Now, this is the detailed steel structure that we developed using advanced steel. Now, and shows the detailed connections. Now, the columns, in order to be placed, they're placed from above. So, openings must be done in the slab and in the roof in order to pass these columns, which should be a careful procedure due to the sensitivity of the slab. Also, the passing of the beams from one room to another requires openings in the wall. Now, taking into consideration that these beams
might deflect a bit, we have placed a foam-like material under it. We leave a bit of void under the beams between them and the walls, so that any deflection or minor deflection can be absorbed by this foam-like material. And now,
this was concerning the major adjustments. However, for the secondary adjustments, we decided to expose all the sandstone walls and fill the voids with non-expansive material that's suitable to sandstone. We decided to replace the two deflected ceilings in circles in the first floor, the kitchen and the room, with the concrete structure. We decided to waterproof and insulate. Now, with regards to the architectural design, I will start by presenting a video. This video shows the transformation of the house and all its historical aspect. We decided to expose the sandstone so that we show this historical feature. In addition to that, the colorful windows indoors will be repaired. Circular air vents and arches will also be preserved. Some features to point out concerning the exterior. We decided to construct a ramp for the people with disabilities. First, we tried to construct a ramp beside the stairs. However, since we do not have a clear distance of at least 32 meters, and keeping in mind that the slope of the stairs exceeds 6 to 7%, which is the acceptable slope for this ramp, we decided to construct a ramp around the garden. The rooftop will have a simple function for breaks, for coffee breaks, and we have to keep in mind that the rooftop has a lovely sea view. With regards to the interior, some changes we have done. The kitchen in the ground floor is kept as is. However, we decided to add a bathroom for the people with disabilities. And as you can see, we have a mixture of modern furniture with while keeping the historical aspects. Here they're shown as the historical tiles. And the mezzanine previously was of unknown use, so we decided to turn the mezzanine into 2 bathrooms. And one more thing, that the mezzanine had an access previously from the kitchen, so there was a stairs in the kitchen. We decided to remove the stairs and make the access for the mezzanine from the main staircase. So this is a section showing the access to the ground floor, mezzanine, and the first floor from the main staircase.
Okay, concerning the MFP, all the 6 sandstone walls of the house will provide good insulation against the cold weather, so no heating system will be needed. But we'll provide air conditioning in order to account for the hot weather. For the mechanical and the electrical connections, all the connection will be on the exterior on the walls in order to avoid draining into the walls. For the water, we'll place 2 tanks, one in the ground and the other on the roof, and will be pumping with the water. For the schedule, our assumptions are 4 labors for each activity, finish to start relationships between the activities, 5 days work week, 8 hours per day. For the calculation of the duration, we account for the productivity of the crews and for the quantities. The estimated duration of the whole project was around 8 months. Okay, here is the detailed cost of our project. The main contributors to the cost was the steel structure, MFP, finishing work, and the foundation works. The estimated cost was around $300,000.
So to conclude, AUB is a leading university in the MENA region, and it has a huge impact on all the region. By preserving such a house, AUB will be a leading example and will raise awareness concerning the importance of cultural heritage. The Ministry of Culture will allow the demolition of such a house only if the ground floor is dismantled, under the condition that it will be reassembled as is for any new project. However, in our project, we have shown the feasibility of such a project, and not only with regards to value, but with regards to the cost, the schedule, and the design. Last of all, let our future be a reflection of our past. We would like to thank all the CEE faculty advisors and all those who helped in the success of our project. Special thanks to Dr. Munir Maqsood, Dr. Aysam Sroud, and Dr. Maysa Dabaghi for their continuous help and support. Thank you.
هلا انتوا
know what AV is planning to do with this house when they bought this property? It's very important.
Let's not talk about.
What is it? Residence for somebody in the top administration, or they want to dismantle it and have another building, preserving the exterior as what was just mentioned. So this is very important to know. What was the purpose to purchase this house? Second, when you look at the foundation using micropipe for such a project, do you think this will solve the potential settlement problem, or a raft would be better solution? Did you look into that?
Yes, we have.
We thought about the raft solution, but we wanted to avoid excavating large areas of the ground, especially since the removal of the tiles, reinstalling them takes time, cost, and effort, and also to avoid removing just more faster time.
Faster construction and less cost.
AUB actually was planning, is planning, I believe maybe to demolish it and put something else instead of it.
But maybe when we give them an actual project that can be feasible, so we can leave the project as is.
All right. Okay. Okay. I guess you can hold for a minute. Okay, just 2 seconds. Okay. Yeah? Can we start now?
Good morning. My colleagues and I are going to present the secondary highway between Matan and Beirut. So to begin with the project outline, we're going to introduce the topic and the objective, followed by the transportation system, the structural system, construction methods, and finally the environmental scoping. So to begin with, the traffic crisis in Lebanon, we're all familiar with it and how it affects us daily. Now, although some possible solutions such as the bus rapid transit, the telepheric highway, or the railway are proposed, however, none of them are implemented. And according to the World Bank, Lebanon is incurring an annual cost of $2 billion. So if we zoom in towards Beirut and break down the kilometers, we can see that 50% are coming from the north and Matan, 15% are coming from Abda and Hazmi, and 35% are coming from the south. So the group decided to focus on the northern entrance of Beirut, where we located two main bottlenecks, as shown. The first is at the Matan Express Highway location and Antelias, and the second is at Juni. So after that, we were provided with an origin destination matrix, which we aggregated in order to reach the following breakdown, which shows the daily traffic from different locations to Beirut, back and forth. Now, the interesting figure in this breakdown was the 46,000, which was found in the Antelias and Nahr al-Mout area. And this number also overlays the first bottleneck. So we zoomed in further towards this area where, as you can see, is governed by four main roads: the Seaside Road, the Shard Hello, the Engel Ahwood Highway, and finally the Matan Express Highway, which, as everyone knows, is incomplete towards its end. Also in this location, we have two main reclaimed areas, as shown. So this highlighted the potential solution to the congestion on this entrance by creating a link between the Matan Express to Beirut by utilizing these reclaimed areas.
Okay, so currently this is the transportation network, and this would be the transportation network after we introduce our modifications. So what we have here is a suspension bridge, which goes from overspans two reclaimed areas. If we zoom into this part of our project, we introduced an interchange next to the slaughterhouse. We introduced here two tunnels connecting Shar al-Hello to an inner road. So this is the inner road. The main issue that we faced here is the location of this inner road. So after our meeting with officials from Dar al-Handasa and Khatib al-Alami, we decided on the right of way of this alignment. And it was based on the fact that almost every building surrounding this road is illegal. So this was the final alignment. But prior to our design, data had to be collected, and this process was divided into two parts. The first part, we gained access to the traffic control center, and through their live feed, we were able to do traffic counts. However, their cameras don't cover all of our entrance points, such as the exits and entrance in the northern corridor of Beirut. So we had to do some field observations. So this is the area of Forum de Beirut. These yellow pins highlight the location of our field observations, while the red pins are the ones from the traffic control center. The same applies to Shar al-Hello and the city mall. So we said that the red pins are the ones from the DCC and the yellow pins from our field observations. So then the data was tabulated and was divided into the afternoon rush and the morning rush. And if we zoom into one of the tables, we can see that we did two 15-minute trials and took their average, and we got the peak hour. And we should note that the data collection was governed by the traffic rush hours. And now Bilal will talk how we implemented these data into AMI software.
So before continuing with our design, we'd like to show you the effect of the projected traffic in the year 2030 if we kept the road network as is without any change. So with a do-nothing scenario, and by accounting for a 2% yearly increase in traffic growth on the main arteries of the main highway, the Jdeida and the Emil Lahoud highway, by utilizing AMI, we found out that, for example, in the main highway, in the year 2018, we have 3286 traffic volume, which increased by 17.52% to reach 3862. Similarly, the Jdeida highway increased by 13.92, and the Emil Lahoud highway increased by 20.88. And as such, when we implemented our design to the road network, the projected accommodation is 2,169 vehicles with a travel speed of 44 kilometers per hour. And this led to a 51.43 decrease in the traffic on the main highway, a 20.8 decrease in the traffic on the Jdeida highway, and finally a 10.76 decrease on the Emil Lahoud highway. Now these numbers are for the year 2018, also it's projected for 2030 to have similar results. Now we're going to go into the structural aspect of the project.
So once the data was collected, we would go on to design standards, and we based our standards on the AASHTO Green Book. So the first section was the geometric alignment of highways, and it mainly focuses on the horizontal and vertical alignment. It also includes the turning radii, the speed, and the rate of vertical curvature for sag and crest. The second section was the design standard and elements. It mainly focuses on the cross-section of the road, like lane width, shoulder, median, sidewalks, and super elevation of the lanes. And finally, the grade separation interchanges, since we had an interchange here. So this section focuses on the ramps according to the highway composition of traffic and the design space. And now Heba and Linda will talk about the structural part of our project.
Regarding the bridge material selection, we chose to do a steel bridge due to multiple factors that favor steel over concrete. Starting with the fact that the steel bridge designs are usually used for long spans. Also, steel components allow faster erection and ease inspection of the structural stability compared to concrete elements. In terms of cost, also, although concrete is cheaper than steel, the decreased weight of steel results in lower erection costs due to the use of lighter equipment, and it also results in lighter foundations. And finally, in cases where bridges are used over high water crossings, where vertical clearance requirements exist, the use of steel girders require less depth compared to concrete girders. As for the bridge type selection, we chose to do a suspension bridge. First, starting with the fact that our bridge crosses a waterway, hence we need a suspension bridge not to hinder the traffic of ships. Second, regarding the materials needed, a suspension bridge requires the least amount of materials for such long spans compared to other types of bridges. It also needs less erection costs. And finally, in terms of aesthetics, suspension bridges are aesthetically pleasing. Hence, having a suspension bridge in Lebanon would act as a landmark, one of its kind in the region. Moving on to the structural system, our proposed suspension bridge is composed of 3 spans. The main span has a length of 750 meters, and 2 side spans having a length of 270 meters each. For the structural components, our bridge is composed first of stiffening girders. In general, for suspension bridges, they can be stiffened either using truss girders or using box girders. For the case of this bridge, we chose a truss system composed of girders in the longitudinal and transverse directions, for it provides higher structural capacity and stability compared to box girders. Each truss member, we chose it to have a HSS section, having welded connections with gusset plates that will act as the joints of the truss. Second, main cables and suspenders. The main function of the vertical suspenders is to transform the loads from the stiffening truss to the main cable, which in turn transfer the loads to the towers. We chose that the main cables would be prefabricated parallel wire strands type of cable, since they have the highest tensile strength and modulus of elasticity, plus they have less flexibility. Regarding the towers or pylons, their main function is to transfer the loads from the main cable to the foundations. We chose to have steel towers since they are more flexible, more ductile, easier to erect. And finally, regarding the anchors, our bridge will be earth anchored, meaning that the main tension from the main cables will be resisted by the mass of massive concrete blocks that will act as end supports to the bridge.
Regarding the materials that will be used in the structural system, a reinforced concrete deck will be used since it's considerably cheaper than a steel floor. Regarding the truss girders and towers, S355 steel will be used since it's most commonly used for highway bridges, and it gives balance between stiffness and strength. And moreover, all steel members will be protected against corrosion using top coats of ethyl silicate and organic zinc. Regarding the design of the structural system, first we started with the design of the deck with the concrete deck. The concrete deck has dead loads and live loads. The dead loads are comprised of the weight of the deck and the weight of the barriers, whereas the live load is comprised of the lane load and the truck axle and braking loads. And having the maximum shear and moment values from SAP analysis, the deck reinforcement design is shown as follows. The design of the stiffening truss is since the bridge is supported by stiffening trusses longitudinally and transversely simultaneously, the structure is designed as a 3D model. This design could be done on SAP 2000 using the dead load and vehicular moving load, which gives the position of the maximum stresses. After that, different HSS sections are investigated to give the section which gives the maximum, which gives the most adequate design against limit states, taking into consideration wind and seismic loads.
All right, you have 1 minute to go.
So I'm going to be introducing the environmental scoping part. And a project of this size requires an environmental scoping in order to pinpoint the conflict areas early on in the project's design and planning phases. This required us to pinpoint the areas of effect. However, not all areas of effect usually present in such projects will affect our project itself. For example, cultural heritage will not be included, as there are no archaeological areas within our project, and the buildings planned for expropriation are not considered landmarks. For the effects themselves, an assessment process has to be made. The assessment process is similar for all the effects considered. First, we're going to introduce the issue and effect. Then we're going to discuss the current baseline conditions for each of the effects. Then we're going to identify the key issues for each of the effects. Then we're going to set an assessment methodology to actually measure the magnitude of each effect. And finally, all of this will allow us to formulate possible mitigation measures. However, in order to effectively do this, we're going to have to use a checklist scoping. This checklist, however, is similar to the one proposed by the Lebanese government through the Decree 8633 in the year 2012. And it follows this setup. And this will allow us to actually decrease the environmental impact caused on the project.
And finally, what's next in our project, we're going to do a thorough cost analysis, followed by the financial expropriation, and finally, a brief geotechnical study. And we'd like to thank our advisor, Dr. Hantoush, for the help in the structural part, Dr. Hani Al-Nabi for the help in the transportation system, and all faculty members who helped us reach this project. Thank you.
Questions?
The results are far less than the results of our bridge system. Now, the good thing about our project is that after implementing it, the bus rapid transit wouldn't need to have a dedicated lane for it because the traffic is very, very much reduced on the highway. So it could be implemented more easily.
Yeah, but I mean, is the 2% actually reduce traffic? Would it still be possible to have a good public transport system?
It might decrease slightly, maybe to 1.5%.
Okay, guys, the presentation.
Okay, hello everyone. We are for Greener Tomorrow, which stands for Fea Ideas, Baby Nicolas, Jim Khodor, and myself, Christophe. We aim to achieve the sustainable construction of a community center in Burj Hamoud, and that is because concrete structures are increasing exponentially and eating up all green areas. Just like Pac-Man, I'm sure you all know the game. The difference is that in this game, sometimes you win, sometimes you lose, but in our context, it is nothing but losses. In this presentation, we will start by discussing Beirut's urban crisis in order to propose a solution. Then the methodology followed will be listed before investigating our design components, which will lead us to assess our project's impact and contribution. Let me start with Beirut's urban crisis. Please follow with me in this video. As you can see, most of Beirut lacks green spaces, apart from Hajj Beirut and a few rich neighborhoods such as Leighton and Rabat al-Baida, in addition to Ayubi and the Saraya Garden. Apart from that, as we move towards the suburbs and the coastal suburbs, you can see again nothing but a concrete jungle, and most of the remaining green areas are vanishing and buildings are erecting in their place. Now, if you move a bit to the northern suburb, which is our area of interest, Burj Hamoud, you can see again that there is not 1 square meter dedicated to green areas, and this rectangular area right here is where we choose to build our community center. So, to translate what you just saw into numbers, Greater Beirut has an area of around 233 square kilometers, of which 50 square kilometers represent road networks, which is a huge number. It has a population of 1.3 million inhabitants, and 0.8 square meters of green spaces per capita, which is far below the 9 square meters demanded by the World Health Organization. Now zooming into Burj Hamoud, we can see that this number diminishes to a shocking 0 square meter per capita for an area of 2.4 square kilometer and a population of 90,000 inhabitants. This picture depicts Burj Hamoud a century ago. You can see the Beirut River bordered by plains and farms, but today none of this seems to exist anymore. To address this problem, we proposed the rehabilitation of a brownfield in Burj Hamoud, which consists of an existing structure which used to be a cement factory, and a vacant land which serves as a parking, and to this community center, which has 4 aspects. First of all, the existing structure will be replaced but will be transformed into a library and an open-air multicultural area. On the east side of the structure, the vacant land will be redeveloped into a public park, while on the west side, we will build a 2-level split parking.
To achieve our sustainable community center, we have followed 10 steps in our methodology. First of all, we have selected the site and surveyed it, followed by the foundation and structural design of all the elements. This has been followed by the parking design and the splitting and division, and the material selection and testing. We have then proposed alternative transportation methods as we limited our parking spaces, and we wanted to be the most sustainable possible, so we used energy generation saving methods and water collection methods. The last 2 steps were designing our garden and doing a financial analysis to know if it's feasible or not. Moving now to the design, we have begun by the site selection that had 4 main criteria for us. The available area, the accessibility, the demographic and socio-economic situation. We have found in one of the quarters of Burj Hamoud, in the Noor Adana quarter, this plot that is an old factory that is 350 meters away from the Dawla roundabout, and it's a very dense and neglected neighborhood, so it's very suitable for us. We then conducted a site surveying with measuring using the chaining method, and we got all the dimensions for our beams and columns and the spacing and the areas that we have. We had an already existing structure of 820 meters square and a total area of 5,500 meters square. Those are the results that we got. And for the structural analysis of the old factory, we wanted to make sure that it could carry our roof, that is PV panels and glass. So we have multiple tests, destructive and non-destructive, and due to many limitations, we only did the Schmidt-Hammer test that yielded to a 38 megapascal concrete strength, and this is enough because we only have an additional load of 0.1 megapascal. We also provided 4 horizontal beams to withstand seismic loads and wind loads because we are in the zone 2B and we have 1.9 kilonewton of wind loads. For now, moving to the parking, that is, we began with the upper level, and we computed live loads, superimposed dead loads, and dead loads, and we got a total of 2 tons per meter squared. It yielded to a 30 centimeter slab of 1,200 meters squared with 2 cores to allow ventilation and to allow light. In this parking, we can see how we can access it. We have 2 ramps with 10% slope, this one, and this is for to go to the lower level. To supporting our roof, we have 32 columns, each having a 0.32 meter squared area with 1% steel reinforcement.
Based on the results discussed by Nicolas, we then proceeded to design our foundations. Due to the light nature of our structure, we had 2 options, either building spread footings or a raft foundation. Although the spread footings is the cheaper alternative, the presence of a water table at 1.5 meters below ground level makes operation costs very high, especially due to the unreliable electricity in Lebanon. As a result, we chose the raft foundation, which is also more expensive but maintenance free. In order to do that, we went on to check for bearing and settlement, which were both turned out to be okay, as you can see. The raft dimensions were thus 82 meters long and 18 meters wide, with a thickness of 0.5 meters, 2 meters below ground level. After that, we proceeded to design the envelope of our library. Due to the availability of excavated soil for the foundation, we decided to use the soil itself in order to build rammed earth walls. In order to do that, we completed 2 tests in the lab in order to check the composition of our rammed earth. The first is the grain size distribution, which yielded a very low clay content, and the second one is the Atterberg limits test, which we used its results in order to compare it to the literature values for the appropriate mixture. As you can see in this figure, the clay content shall be between 20 and 35%, whereas we only have 10%, which means we should enrich our soil with clay. Moving on, we proceeded to design our parking based on the Lebanese parking regulations, and were thus able to provide 88 parking spots, as you can see in this figure, including 4 handicap spots, with access to the parking between the parking and community center provided by a ramp and staircase. Since no parking will be provided for visitors, we aim to encourage alternative transportation methods. The most readily available one is the public transportation, namely the bus and taxis. As you can see in this map by Zawari Beirut, the Dawra roundabout is a major hub for public buses. Additionally, the old Beirut Railway is only 500 meters from our community center, and this makes it within access in case there are plans to rehabilitate it in the future. Last, we studied the main streets around our plot and found that they are mostly between 10 and 12 meters wide, which makes the implementation of a 1.5 meter bicycle lane feasible, and we thus provided a 20 bicycle parking in the community center in order to encourage this practice.
The aim of our project is to integrate sustainability in every aspect of it. So the 3 main components of sustainability that we use are energy saving and generation, water collection, and landscape design. Starting with energy saving, our main focus was heat insulation, natural light, and natural ventilation. Since our library is in the direction of the north, we chose to design our walls and windows to face the south and thus not face direct sunlight. In the same way of thinking, we placed the skylight on the roof facing the north. The parking was split in order to allow for natural light and natural ventilation to go through the lower level. To generate energy, what we did was place solar panels on the roof that would generate 120 kilowatts per year. This means that our project would be self-sufficient energy-wise throughout the year. Regarding water collection was done regarding to the months of the year. During the rainy months, rainwater was collected from the rooftop to the lower level of the parking, which would amount to 600 meters cubed of rainwater annually. During the dry and hot months, water, although it's a small amount, water would be collected from the air conditioners and amount to a 20 meters cubed of condensate annually. Finally, throughout the year, water will be collected and go through these 2 water tanks that are present in the lower level of the parking, and amount to almost 40% of our water demand for the whole project. Landscape design was done. First, we placed Mediterranean trees all around the project because they require low water and would provide shade all around the park. In the center of the park, there's 350 meters cubed of urban farm that will be planted. The main crop planted will be orcas because of their historical plantation, but cucumbers, cabbage, lettuce, radish, onions, etc. would be also planted in it. Finally, regarding the financial analysis, we came up with a total cost of $835,000 for the whole project, which, if you compare it to what it would have cost for a traditional building of the same type, is 40% less than a traditional building, which is good because of the sustainable aspect.
As discussed by my colleagues and I, our project is able to impact the community in a variety of ways, especially that it can create a space for public leisure in Beirut at no cost. Additionally, it is a brownfield rehabilitation, which is a practice that is becoming more and more popular and that should be encouraged in order to preserve the last few remaining green areas. We would like to thank our advisors, Dr. Bilbasi and Dr. Salam, as well as all the CEE faculty that helped us throughout the project, and of course Mr. Antoine Alamed for allowing us to use his land plot, and Mr. Agri Margasarian for providing us with historical and cultural knowledge about Bish Hamoud. Thank you very much.
$25,000. If you divide that by the square meters that you provide to this project, how much is the rate?
We had 500 square meters, so that would amount to
500. يعني حوالي 1,600.
How much less? About $150 per meter square. $150 per meter square.
Only?
Yes.
We have 5,500 meters squared and a total cost of $835,000. You have to keep in mind that the library itself is being rehabilitated, so the structure is already standing. So the only work that has to be done is the excavation for the parking. And also we will be using earth bricks which are available outside.
Division of the cost of such project? Excavation, foundation?
Yes, we showed it in the last slide.
It will be by email.
Okay, sure.
Good morning, everyone. My name is Ali Ismail, and these are the colleagues Muhammad Hamandi, Ali Nasruddin, Jalal Shaheen, and Abdul Karim Ismail. Today we're going to present to you about sustainable refugee camps. When it comes to our project, the study was based on a building located in Saida. This building was mainly built for university purposes. It was Al-Imam Al-Uzai University. However, in 2014, it was transformed to a vertical refugee camp. A refugee camp that had 4 floors, 2 basements, and is made out of 2 blocks that form an L shape. Also in this building, it happens to be that we have about 200 families living now. Each family has about 4 to 5 members. The current situation is miserable. From our first visit, we noticed many problems. Many problems related to air quality, waste management, water waste management, and many problems related to the parking system. Also, we found that there's a lot of safety hazards. So we decided to come up with a sustainability plan. A sustainability plan that has 4 criteria, main criteria. We have the water cycle, green roofs implementation, indoor air quality assessment, and more about the civic engagement strategies that can be used. Now I'll give the floor to my colleague, Jalal, to tell you more about the water cycle.
So the only source of water is located near the playground in the mosque. The main issue was found out to be that refugees tend to fill up buckets in order to have access to water. Based on municipality statements, we were told that the water is labeled as drinkable water. We decided to double check that by taking samples into the environmental lab at AUB, and we tested for pH, total dissolved solids, conductivity, and many other tests. We compared them with international standards, and we found out that the total hardness is around 330 milligrams per liter, which makes it not conformant with these tests, which can let us say that this water can be classified as an extremely hard water that can be treated using a softening process. The next step is to pump water into concrete tanks allocated on the rooftop, where the chlorination process will occur. The chlorination process will be like dropping sodium hypochlorite into the water, as it will be used using a flow control measurement by a chlorine pump in order to add the disinfectant in the water in case any further contamination will occur. Another source of water that needs to be considered will be discussed by my colleague Hans.
Okay. As you have said before, there is only one source of water in the camp, and it's drinkable water. Plus, this water is subject to high water consumption, and we are facing a problem in the camp, which is high wastewater generation. So we thought about why losing all the wastewater generated, while we can recycle and reuse part of it. Wastewater is separated into 2 parts, black and grey water. We are concerned about recycling and reusing grey water. On camp, grey water is originating from showers, kitchen sinks, laundries, and from ablution activities. Water coming from ablution activities are free of chemicals, so this will dilute the grey water and will facilitate the treatment process. And grey water does not include toilet waste. The recycled grey water is intended to be used for flushing purposes in public toilets and for irrigation of green roof that will be discussed later. We compared the standards of irrigation water and flushing water, and we want the treated grey water to follow these following standards: a pH between 6 and 9, DOT 5 less than 10 milligram per liters, and turbidity less than 2 NTU, and also fecal coliforms of seed. Now let's elaborate more on the water cycle concept we are planning to execute. First, the municipal water will be stored in basement tanks, then will be pumped to 2 water tanks on roof. Tank C will serve water for drinking taps on each floor, and Tank B will be allocated for room services and for public toilet services other than flushing. Then the used water will be stored in a storage tank in basement and will be treated as grey water. Any overflow will directly go to the municipality wastewater drainage. And after treatment, this water will be pumped to a third tank on roof, Tank A, which will be allocated for flushing in public toilets, for irrigation of the green roof, and for the corridor services. After usage, this water will directly go to the municipality wastewater drainage. As for the grey water treatment, we are designing a plant which consists of 3 processes. First, the water will pass through a screen and then settle in a septic tank for removal of particles and reduction of organics. Then it will pass through an activated sand and activated carbon for filtration, and afterwards it will be subject to chlorination for disinfection from microorganisms.
After noticing the empty space that we have on the rooftop, we decided to add a green area that will improve our sustainability plan. The green roofs are known for their benefits. They can help with stormwater management, energy demand reduction, livelihood enhancement, and the most important part, it can help us, in the case of refugees, to be a food source. When it comes to the design concept, we're going to design the green roof in a way that takes into consideration the sustainability, the accessibility for maintenance. Also, it's made in multiple layers in order to protect the roof surface from any root penetration. When it comes to the vegetation used, since it's food, we need to use a specific type of plants that does not have any extensive vines or big-sized vegetations. Now I'll give the floor to my colleague Hamandi to tell you more about the indoor air quality.
Okay, so in order to study the indoor air quality, we first performed a qualitative walkthrough analysis. In this analysis, we found out that on average, more than 5 people are living in less than 30 meter squared rooms, as shown in the top left corner. And some of these rooms have wooden parts like the ceilings, which favor mold growth. We also observed that there was evident moisture on the floor due to the continuous cleaning and drying of the laundry. Now, moving into the quantitative testing, we performed 2 types of tests. In the first test, which is air sampling, we took air samples in order to test for bacterial and mold growth. And in the second test, we used a data logger in order to measure the concentration of different gaseous pollutants in the air. Now, an important note on the data logger, it should have been kept in each room for around 8 hours, but we actually kept it for 15 minutes. So these results are actually underestimating the real situation. So for the results of the temperature, we can see that the least room is 4 degrees hotter than the outdoor air, and some of the rooms are exceeding the standard or the maximum standard temperature of 24 degrees Celsius. For the relative humidity, we can see also that several rooms exceed 60%, which leaves them feeling uncomfortably wet. So for the carbon dioxide levels, although they are already high, we expect them to be much higher during night hours, because all the occupants will be in the room or sleeping. And as we can see, some of them exceed the 1000 ppm standard, which is due to the heavy congestion in the rooms. Now, as for the total volatile organic compounds and carbon monoxide, we didn't find any problems with those, as we only found the extremely low traces of them. Now, moving into the air sampling tests, The air samples were sent to a lab where they were examined, and we found out that there was heavy mold growth and bacterial growth in most of the rooms, which indicates a damp environment. Now Abdul Karim will talk about the civic.
I'll talk about the civic engagement. So, first of all, civic engagement comes in three terms. First term is the voluntary service, and the second term is the youth service, and the third term is public concern. But in our case, we'll be specific to the public concern. So, which defines as the individual and the collective actions to identify and address the issues of public concern. So the benefits of this could be communal and individual. Communal in terms of how this can improve the infrastructure and the health of the community itself, and individual as in the social and life skills of the refugees. So helpful strategies are the agricultural training for the refugees and the refugees' employment, and adding a playground court, and limiting safety hazards of the camp, and the luminosity of the camp itself, and the garbage disposal awareness. We're going to study the feasibility of each one, and choose which is more applicable and which fits most complex, and which is within budget itself. As a conclusion, after combining all four criteria that we have, we can say that we have
a sustainable refugee camp.
We had a sustainable refugee camp, and this can help us using it for the later use as for the future use in terms of for the future use of the complex, which is a university, which could be implemented also in the university. I would like to thank you all for listening, and I would like to thank our advisors and our people that helped us during the credentials. Not the PowerPoint, the project, especially the civic engagement office. Thank you. Any questions?
Quick question. The roof that you're going to plant,
yes,
we're going to use as a green roof, can hold the weight of the additional.
Yes, exactly. We studied it, and the superimposed dead load that's from the roof, it's very minimal compared to what the structure can handle. Any questions?
Thank you.
Thank you.
Okay. Okay. You all know that the session is about FYP. Again, it was, I think this was an excellent presentation experience. For me at least, I was very happy to see things this way. This is showing how your FYP has been developing. You will have the chance to do this again. Maybe you have even more time to do that for next FYP presentation fully if you have more to do. And as you know, and you've been asked to stay for this session because this is going to be quite also an enlightening session today with Dr. René Morgos. I'll introduce him. Then we can have just 5 minutes. You can have your quick coffee, but please, in 5 minutes we need to start, not to be late. Maybe I'll do the introduction later. Okay, but please, we're not going to police or anything. You have to come back as FYP students. Okay. Otherwise, will catch you outside.
5 minutes. 5 minutes.
Yeah, but please again, let's come back in 5 minutes. Get your coffee, get anything you want, some snacks, and.